In this video, I'd like to add some more rules of the game to the code, but I'd also like to make it a little bit more informative for the players. So I'm going to add a new variable called message code and set it initially to have a value of 0. And we're going to use this variable to allow the message that's printed above the game board to be more flexible and respond to whatever situation might be happening in the game. So the default value of 0, I want to add that to my if condition with an AND connector. So if player 1 is playing and the message code equals 0, we'll print player 1's turn. And then let me change this to an else if player 2 is playing, so if it's not player 1's turn, and again the message code is equal to 0, we'll simply print player 2's turn. And after we print the message, I'm going to set this back to the default message code value of 0, because elsewhere in the code we'll be able to change the message code to something else, which will allow us to then print some other message. So the code can really only handle a limited set of inputs. It can take the letter Q to quit the game, or A, B, C, D, E, or F to choose one of the bins. Other than that, we can't handle the input that's given. And so as a default, last time I set up this chosen bin value of 0, but that's not really the best way to deal with this. So I'm actually going to get rid of that line, and instead, after this whole big bunch of if and else if statements, I'm going to add a final else command at the very end. So if none of the input values are entered, Q, A, B, C, D, E, or F, will fall into this else block, and this is where I can use that message code variable. I'm going to set the message code equal to -2. So if this happens, it means that the input was invalid. So let me add a comment to help us remember that. We get a message code of -2 if the input is invalid. And now if I go back up to the message section, I can add that as a new possibility. So if it's player 1's turn and the message code is equal to -2, let me set the message to equal something like invalid input, try again, player 1. And then we can create a similar message if it is not player 1's turn. In other words, if it's player 2's turn, I can make that adjustment and then adjust the message to say player 2 at the end. So before we test the code and see that this works, let's kind of look carefully through it. What we haven't done in this block is set the chosen bin value, but what I see in line 80 here is the chosen bin is going to be accessed. So I actually don't want that to happen. So to avoid that problem, let me do a couple things. I'm going to set the chosen bin to equal -2, and then ahead of this line of code I can check to make sure that the chosen bin value is an appropriate value to plug into my bin amount array. So what I need the chosen bin to be greater than or equal to 0, because then it will correspond to one of the indices. And so I can tab that over now. And now let me also add this switch between player 1 and player 2 into that if block. because I don't want to switch between the players if the chosen bin isn't an appropriate bin to be chosen. So if I run this new code, we see our game board. If I choose C, the value of bin C goes to 0. If we choose B, the value of bin B for player 2 goes to 0. But if we type in something random like Y, we see invalid input, try again player 1. So it didn't switch to player 2, it stayed with player 1 and gave them another chance. If they choose D, for example, it switches to player 2. But now notice what happens. I could choose as player 2, I could choose B again a second time, and it switches to player 1, but that's a bit of a problem because one of the rules of Mancala is that you have to choose a bin that actually has stones in it. So we need to remove the possibility of choosing an empty bin. So we can do that here. Let me define a new variable called giveaway pile, which will store the bin amount from the chosen bin. So before we set that number to 0, I want to record how many stones were actually in that bin. And that's what I do with the giveaway pile. And now I can check to see if the giveaway pile is greater than 0. And if that's the case, we'll switch between player 1 and player 2, but if not, we'll create a new message code. This time, let's say -1, and this message will indicate that an empty bin was chosen. So if a player happens to choose an empty bin, we're going to not let them do that and tell them to choose a bin with stones in it. So I can go back up to my messages and add a new line of messages. If it's player 1's turn and the message code is equal to -1, I want the message to say something like, you must choose a non-empty bin. Player 1. And a similar message, of course, for player 2. Oh, and looking at my code here, I happen to catch that I have this little red mark under the equal sign because that should be a double equal sign, because I'm testing the value of the message code variable. And now if I run the code again, we can test this out. If I choose bin F, we see a little bit of an error. I didn't place the integer signal in front of the giveaway pile, so Python is telling me it can't interpret that. So let me add that in. When I make this comparison, I need to tell Python to interpret the giveaway pile variable as an integer and not a string. So now let's run the code, and if I enter the value F, we see a 0 in bin F. Let me choose B for player 2, and if I choose F again for player 1, I get the signal to choose a non-empty bin. So it won't let me choose bin F a second time. If I choose bin D, we see a 0 appear in that bin. So I'm going to end this tutorial here. Next time, we'll work on distributing stones that are taken from the bin, distributing them to other bins on the board. If you're familiar with Mancala, you may know that the stones that are picked up from a bin get placed one by one counterclockwise around the board. And so we'll work on including that in the code next time.